Welcome back to All This Math. This is Professor Parker, and we're going to be solving and graphing an inequality. All right? Don't get intimidated by this. All right? You can do this. Don't get intimidated by it. Even if it has fractions in it, right? Don't get intimidated by it. But I'm going to show you a trick for clearing out fractions. Kwame. Chill, bro. I'm going to show you a trick for clearing out fractions, right? First thing you do is you draw brackets around the entire inequality. It's an inequality, not an equation, because it's got an inequality sign. So we're going to do this. We're going to do this, right? Now, I'm going to multiply this entire inequality by the number 6. Now, why am I multiplying by 6? Why not 8? Why not 4? Why not 10? Why not 25? Why not -8? The reason I'm multiplying the entire equation by 6 is because I look at all the denominators. All the denominators. So I look at every fraction, the bottom number in every fraction. 3, 6, 2, 6. This is not a fraction, so this don't really count, right? 3, 6, 2, and 6, the least common multiple, aka the LCM, right, is 6. 6 is the least common multiple of 1, 2, 3, 4, these 4 numbers, right? Why? Why is that? Because 3 times 2 equals 6. 6 times 1 equals 6. 2 times 3 equals 6. 6 times 1 again equals 6. 6 is the smallest number. That's what the L part, the L stands for least, smallest, right? Smallest number that all of these 4 numbers, really 3 numbers, can multiply into, that they have in common, right? That they all multiply into. It's the number 6. So that's your LCM. So when you're doing problems like this, what you want to do is you want to find your LCM. Your LCM is 6. So you're going to multiply everything by 6. Everything. Now, even the parts that aren't fractions, like this 2x right here. A lot of people make the mistake and they say, oh, well, that wasn't a fraction, so I don't got to multiply by that. Yes, you do. Yes, you do. When you multiply, this number gets multiplied by everything in the inequality. Or if it was an equation, everything inside the equation. Not just the stuff that's actually fractions, right? Everything gets multiplied. Everything gets it. All right, so look. This is going to turn into a 4, or a 4x more appropriately, right? Because what's 6 times 2? 12. What's 12 divided by 3? 4. 4x, right? This is going to turn into a 1, because what's 1/6 of 6 is 1. Or 6 times 1 is 6 divided by 6 is 1. So we got to understand though, right, why this became 4x. So you got to know how to multiply whole numbers by fractions. Whole numbers by fractions. You got to know how to do that. And I'm going to tell you something else. What you're not doing is you're not doing 6 times 2 and 6 times 3. You're not doing it. That don't even make sense. You know why? Because 6 is really 6 over 1. It's really 6 over 1. So if it was 6 over 1, that means that you're doing 6 times 2 and the invisible 1 times 3, right? Which gives you 12 over 3. And 12 divided by 3 gives you 4. What a lot of people out here be doing, they multiply the 6 by the numerator and the denominator. Tripping. That's not how you do multiplication. That's not how that works at all. So you got to make sure you're not out here, you're not one of these people making that mistake. Because that's tragic. I'm trying to tell you. All right? So 6 times 2/3 is 4. 6 times -1/6 is 1. Well, -1. 6 times 1/2 is 3. Because the half of 6 is 3. Plus 6 times 1 divided by 2 is 3. Right? And then that's greater than. And 6 times 7 over 6 is just 7. Because that's 6 times 7, which is 42, over 6, which is 7. Not 42 over 36. It's not 42 over 36. I repeat it again for the people in the back. It's not 42 over 36. I'm telling you, if I had $1 for every time I seen a student make that mistake, you know what I'm saying? I might not be here right now making these videos, right? But anyway, so 6 times 2x is 12x. Don't forget, multiply the 6 by everything in the inequality. Now, we got rid of all the fractions. That was the purpose of us doing that, to get rid of all the fractions. We got rid of all the fractions. Now, let's do something else. Let's combine some like terms. So, all right, so I say I got a 4x and a 3x from over here. So I'm going to put them together. 7x minus 1. What I'm really doing is I'm trying to simplify the inequality. I don't need all these terms. So instead of having 5 terms, now I got 4. 1, 2, 3, 4. I used to have 1, 2, 3, 4, 5. I want to simplify everything because remember, my ultimate goal is to isolate x by itself on one side of the inequality, preferably the left-hand side, because we read from left to right. So I want to be able to say that x is either greater than something or x is less than something, right? If you got the x on the right-hand side, it ain't the end of the world. It's just not my twist. That's not what I like to do. I like to have my variables on the left-hand side. That's just how I get down. That's how most people get down. It don't mean it's wrong if you want to be different and just have your variable on the right side. You could do that. But anyway, I got x's in too many places. I got an x over here and I got an x over here. So I need to combine those. But I can't combine them until I put them together. So I like to combine them by using a method called transposition or transposing. Right? So watch what I do. Watch this. Watch this. 7x minus 12x is greater than 7 plus 1. Now take a minute and just look at what I just wrote. I just wrote 7x minus 12x is greater than 7 plus 1. So this is one of the things that like teachers and professors like to do in class, and they sometimes, unfortunately, they don't explain why they did it. They don't explain what justified them to be able to do it. They just do it and they just expect you to know why it happened, right? I'm gonna explain to you why it happened, all right? The 7x was already on the left side. It's still on the left side. The -1, I transposed. That means when you move something from one side of a problem to the other, or one side of an equation to the other, or one side of an inequality to the other, I transpose the -1 from the left side to the right-hand side. But when you do that, you must change its sign. So this was a -1. It became a +1. When you move it over to the other side, the sign changes. Switch the side, change the sign. Switch the side, change the sign. Think of it that way, right? Now, where did this -12x come from? It came from the right-hand side. Why am I doing that? Because I want all the x's together. I want all the x's to be together. That's why. So it was a +12x on the right side. Now it's a -12x on the left side, right? Now, the 7 was already over there. Like I said, we already talked about the 1, where the 1 came from. It was -1 on the left side. Now it's going to be +1 on the right side. So we combine the x terms, and these are constants. 7 and 1 are constants. Constants are numbers that are not attached to variables. This is plain 7, this is plain 1. So now I can combine like terms. So watch this. Now I'm going to have -5x is greater than 8. -5x is greater than 8 because 7 minus 12 is -5. So now I got -5x. 7 plus 1 is 8. So now I got 8, right? So -5x is greater than 8. So now what's going to happen is I'm going to get rid of -5. And I get rid of -5 by doing division because division is the opposite of multiplication. -5x means -5 times x. All right? Kwame, chill with that noise, bro. We'll take that over there. So I'm dividing by -5. On the left side, I'm also dividing by -5 on the right side. So the -5s cancel out, right? Leaving you with just x, because -5 divided by -5 is 1. So that leaves me with 1x, right? Now, I just divided by a negative number. Whenever I'm solving an inequality, if I divide by a negative number, that means my inequality sign needs to flip. It's got to flip in the other direction. It's got to flip in the other direction. So instead of being greater than, now it's going to be less than, right? So I got 8 over -5. 8 over -5, right? So I got x is less than 8 over -5. Bro, I just told you. You got to chill. Stop playing with that. You can't play with that in here right now. Okay? Take that over there. All right, so anyway, x is less than 8 over -5. All right? Now, that's the solution. So that means that x is less than any number. X is any number that's less than -8 over 5 or -8/5. Let me convert this into a mixed number, right? So how many groups of 5 fit into 8? 1, right? So I'm going to also say negative, it's negative, and then 1, how many left over? 3. So negative 1 3/5. So x is less than negative 1 3/5, right? So x is less than negative 1 3/5. And now this is our solution. So any number that's less than negative 1 3/5, so that means like negative 2, negative 1 4/5, you know, negative 1 9/10, right? Negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. You know what I mean? Like any of those, right? So here we go. 0, negative 1, negative 2, positive 1, positive 2, positive 3. Negative 1 3/5 is less than negative 1, but it's greater than negative 2. So it's in between these two numbers, negative 1 and negative 2, negative 1, negative 2. It's in between these two numbers, right? Now, the question is, when I draw my circle, should my circle be empty or should my circle be shaded in? My circle should be empty because x is not equal to this number. X is not equal to this number, right? It's only a boundary point. It's a boundary point. So draw your circle like that. And then next question is, where's my arrow going to go? Should my arrow go to the left or should my arrow go to the right? My arrow should go to the left because where are all the numbers that are less than negative 1 3/5? They are to the left. So that's where I'm going to draw my arrow. So I got negative x negative 1 next to negative 1 3/5. This is what the graph looks like. This is the solution. And we about to be done. Kwame, you want to come say bye to the people?
Yeah.
All right, come on, bro. Hurry up. Now's your time to make noise. Now the time to make noise, all right? Say bye to the people.
Bye.
Peace out.